Okay, so esterification is when an alcohol reacts with a carboxylic acid in the presence of a catalyst. In the presence of a concentrated sulfuric acid, and then they form an ester. So it's basically alcohol plus carboxylic acid giving you an ester. So in the presence of a concentrated H2SO4 sulfuric acid. Okay, so this is very simple. You just need to know and remember your functional groups. So your alcohol, you know, it's a carbon bonded to an OH, and the carboxylic acid, it's a carbon double bond oxygen single bond OH. Just remember those functional groups. So here, water will be eliminated during the process. Okay, so you can also be asked the uses of an ester. When we do the actual practical, you will see, and also you'll be able to smell how they smell. So esters are used for what do you call, just to, I don't know how to put it in English, like to make things smell good. So even in nail polishes they put esters. Yeah, and what else? So esters, just remember those uses. I'm gonna check again on those uses. And yeah, so let's see how does the reaction take place. So you have an alcohol, for example, let's use prop 1 or, and the carboxylic acid, let's use butanoic acid. So this is what we have. Prop for 3 carbons, so we have an OH, and then we're going to have 7 hydrogens. So butanoic acid, we have 4 carbons. So when you're asked to show these reactions, it's best to put the functional groups next to each other. Like instead of putting the functional groups this side, put them this side and that side, so you can show how the reaction takes place. So we have a double bond oxygen single bond OH. Okay. So this takes place in the presence of concentrated sulfuric acid. So basically what's going on here, since water will be eliminated, the alcohol will give away the OH, and the carboxylic acid gives away the hydrogen. So if you have to show the arrows, so you can simply say an arrow pointing to the hydrogen to form H2O, and then this oxygen from the carboxylic acid will go and attach to the carbon from the alcohol. Okay, so this is how the product will look like. We're gonna start with the 3 carbons from the alcohol as it is, and then here we have 2 hydrogens. Then we're going to show the bond between the oxygen, so from the oxygen to the carbon, so there is the bond. then from the oxygen to the other carbon from the carboxylic acid, which is bonded to double bond oxygen, right? Okay, I made a mistake. This is not supposed to be, this is an extra bond, so it's supposed to look like that. Apologies for that. And then we have 4 carbons, 1 2 3 4. So that is how you show how the reaction takes place, and this actually carries a lot of marks. It can be 5 marks like this. So if you have to name, just know that the name of an ester, so here is your ester, so here's the ester. So the name of an ester, you have an alkyl, which is a substituent, and then from the carboxylic acid, we're going to give that carboxylic acid a suffix O8. So this from the carboxylic acid, and the alkyl group is the alcohol. Alkyl means it's now treated as a substituent, like methyl, ethyl, like that. So right now our alkyl is prop, 3 carbons from the alcohol, so the name will be propyl. Then our carboxylic acid is 4 carbons, then it means we have butanoate. So the suffix attaches to the carboxylic acid. That is esterification. So in the next videos we'll be doing examples combining all those reactions. So what you can do, just take a minute, go through these notes before you can look at examples. And then when I'm doing the examples, try to attempt the examples first before you check how I did it.